Okay guys, I just thought I would make you a quick video in case you needed some help with your ALEKS assignment. Remember that this is due before you come to class on Monday. We will be doing an activity that involves Starburst, and I want to make sure that everyone can participate. We're also going to be having our probability test, and I want you to make sure that you're prepared. So these questions right here, these are just like questions that you're going to see on your ALEKS. They may be different numbers, but same types of questions. So when you look at question 1, before we do this one, I want you to remember that when we talk about probability, if something is not going to happen, like it's impossible for it to happen, then that's going to be a 0. If it's absolutely certainly going to happen, okay, so if it's certain, that's going to be 100%, or we would say it's a 1. Okay, so probability falls somewhere in between of 0 and 1. 1 means it's certain, 0 means it's not going to happen. And then if we do half of that, anything that's less than the 1/2, then that's unlikely. And anything that is bigger than 1/2, that is likely. Okay, so it says there are 2 boxes containing only black and green pens. Box A has 4 green pens and 4 black pens. Box B has 11 green pens and 9 black pens. A pen is randomly chosen from each box. List these events from least likely to most likely. So if it's going to be closer to absolutely for certain happening, that's going to be most likely. If it's going to be closer to not happening, then that would be least likely. Okay, so event number 1 says choosing a black pen from box B. Event 2 says choosing a green pen from box A. Event 3 says choosing a green or black pen from box B. And event 4 says choosing a purple pen from box A. So I'm going to start with knowing that event number 4 is the very least likely to happen, because if we look at box A, you can see that there's not even any purple pens in the box. Okay, so we're going to make this one a 4. Okay, now let's go back up to event 1, choosing a black pen from box B. So on box B, there are more green pens than there are black pens. And then event 2, choosing a green pen from box A. And then event 3, choosing a green or black pen from box B. Well, we know that event number 3, this event right here, it's probably the most likely to happen, because in box B, we only have green pens and we have black pens. So this event, choosing a green or black pen from box B, that is most likely to happen. Like that one's going to be for certain. Okay, now we just have to decide event 1 or event 2. Which one is more likely than the other? So event 1, choosing a black pen from box B. That one is probably not as likely as choosing a green pen from box A, because in box B there are less black pens than there are green pens. So we would say that event number 1 would go here, choosing a black pen from box B. Oh, sorry, that would go here, and then we would say number 2 would go here. Okay, so that's how you do those ones. Let's look at this other one. It says, question number 2, a bag contains 7 tiles labeled A, B, C, D, E, and F, and G. One tile will be randomly picked. What is the probability of picking a letter that is not a vowel? Now this part right here, this is super important that you read carefully. We want the probability of picking one that is not a vowel. Okay, so when we look at these letters, the ones that are not vowels would be B, C, D, F, and G. So there's a lot of those letters that are not vowels. There are 1, 2, 3, 4, 5, 6, 7 letters in total, and 1, 2, 3, 4, 5 of them are not vowels. So when it says, what is the probability of picking a letter that is not a vowel? That would be 5 out of 7. 5 out of 7 of them are not vowels. Okay, next one. Okay, this one is kind of like the one I just did. Let's look at this one. Question number 4. A math class has 4 girls and 4 boys in 7th grade and 7 girls and 3 boys in 8th grade. The teacher randomly selects a 7th grader and an 8th grader from the class for a competition. What is the probability that the students she selects are both girls? Okay, so the probability of choosing both girls. So this is going to be a compound probability. So for the first event, let's talk about picking a girl out of the total of 7th graders. So there are 4 girls and 4 boys in 7th grade. The probability of picking a girl would be 4 out of 8. And then if we do a probability of the second event, so this one right here, there are 7 girls and 3 boys. So the probability of picking a girl would be 7 out of 10. Okay. And then the probability of picking a girl both times, that's a compound event. So we're going to multiply these together, and that would be 28 out of 80. And then we just need to simplify that. And that would be a 7 out of 20, okay? Because this asks for a fraction in simplest form. So that would be the probability of choosing both girls. Okay, next question. Each bag below has 7 marbles. Justin closes his eyes and picks a marble from each bag. I think that you guys should be able to do this one. Remember that certain is the 1. It's absolutely for sure going to happen. That's like 100% going to happen. And then a 0 would mean that it is impossible. So it's for sure not going to happen. We've done lots of questions like that. For question 6, this one is one of those ones where the sample space has been created for you. These are the ones that we worked on in class on Thursday. It says one spinner has 2 sections. They are marked A and B. Another spinner has 5 sections. They are marked 1, 2, 3, 4, and 5. The 2 spinners are spun, and then we have a tree diagram showing the possible outcomes. Okay, so the first spinner has an A and a B, okay? So if you spin the first spinner, you're either going to get an A or you're going to get a B. And then the second spinner has 5 sections, and they're marked 1, 2, 3, 4, and 5. So for the second spinner, if you spin an A on the first spin, for the second spin, you could get either a 1, a 2, a 3, a 4, or a 5. So these are all outcomes if you spin A the first time, okay? And then if you spin B the first time, so if we spin B the first time, on the second spin, we can get either a 1, a 2, a 3, a 4, or a 5. So these are all the outcomes if you spin B the first time. So how many outcomes are there? We would want to count all of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 possible outcomes. Next question, how many outcomes involve landing on a 2 or a 5? Okay, a 2 or a 5. And I'm going to go ahead and mark these in a different color. So this one has a 2, this one has a 5, this one has a 2, and this one has a 5. So if it says how many outcomes involve landing on a 2 or a 5, we would say 1, 2, 3, 4 out of the 10, and then that would simplify to 2/5. And then the last question, how many outcomes involve landing on an even number? Landing on B and an even number. Okay, so now if we need to land on B, we're only looking at these ones, and then all of the even numbers would be this one and this one. So there's only 2 of them that have a B and an even number, 2 out of the 10 possibilities, which simplifies to 1/5. Okay, let's see, on this one, the thing I want to talk to you about on this one is this right here is saying what's the probability of A happening? This is what's the probability of B happening. That's what this means right here. This is the probability of event A happening. This is the probability of event B happening. And then on this one, the thing I want to remind you about here is that if the experiment actually happened, then that is called experimental probability. So if the spins were actually made, this was the outcome. This is how we would calculate the theoretical probability. So for the theoretical probability, it says the spinner shows 5 equally sized slices, 3 gray, 1 white, and 1 black. So this is the spinner right here. And you can see it has 3 gray, 1 white, 1 black. And then it says that she spun the dial 200 times and she got these results right here. Let me draw a little arrow there. And when it says, assuming the spinner is fair, compute the theoretical probability. So that is where you're using this. This is the theoretical probability. So out of 5, how many times would you land on white or black? Okay. And then when it says compute the experimental probability, that is where you're using this chart, and there are 200 possible outcomes because she spun the dial 200 times. Okay. I think that should be helpful for you. If you have any questions as you're working on this, feel free to email me. I'm happy to help you. Make sure that you get this done before class on Monday. Thanks, you guys. You're the best.